In today's lesson, we're going to go ahead and graph some other things. In the past, all you've graphed really are lines. Today, we're going to graph some other shapes. And the first one I want you to graph is the function f of x equals x squared. So we're going to graph the function x squared. Now, in general, when you're asked to graph something and you have no idea what it looks like ahead of time, you can always make a table, meaning you draw an x column, a y column, and you can pick any numbers you want for x. So I picked a good range of some negatives, some fractions, 0, and some positives, and that gives me an idea of what the shape looks like. And all I have to do is take this x value, plug it into the formula for x, and then simplify. So if I do negative 3 squared, I get positive 9. Negative 2 squared is 4. Negative 1 squared is 1. There's a lot of students that don't know how to do squares of fractions. We don't know how to do negative 1/2 squared, and it's very, very simple. All you have to do is square the top and square the bottom. So if you do 1 squared, you get 1, and 2 squared, you get 4. So 1/2 squared is 1/4. And then we'll continue, 0 squared is 0. And for some reason, there's a 1 twice here, so I'm just going to cross this one out. We'll get to that one later. 1/2 squared is still 1/4. Positive 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then all I'm going to do is just graph these as ordered pairs. So negative 3, 9 is right here. Negative 2, comma 4 is next. That's here. Negative 1, comma 1. Now when you're graphing negative 1/2, comma 1/4, you're just going to have to do the best you can to estimate it. So negative 1/2 is halfway to the left. 1/4 is barely above the line, a quarter of the way to 1. So it's somewhere like right there. 0, 0. And what you'll find is as you graph the rest of your points, they will mirror the other side. So you can see there's a reflection going on here. And that's kind of how I want to introduce this. So when you graph x squared problems, if you see an x squared in it, you see a little squared symbol, your graph is going to resemble this. It's going to make basically a U. But really important, we graphed V's in the past. That's when you have bars, they made V's. But when you have squares, they don't make V's, rather they make U's. They make these like curved figures. So big difference there. And what you just graphed when you see a little squared is called a quadratic equation. Quadratic means you have a little squared symbol. Your exponent is 2. So just like every function has its own formula that tells you quickly how to graph it, same thing here. Now, we talked in our last couple videos about h and k representing the vertex, which would be the very tip of the V. Same thing here, except it's the tip of the U. And we said how f of x was the same thing as y. And all formulas have x's in them, so the only thing that's new here is the a. Unlike lines, a is not slope right here. We don't have a slope of this graph. We have what's called a stretch or a shrink factor. So there's a different technique to graphing quadratics that you have not learned yet, but you're going to learn in this video. In order for you to be able to do this, you have to know how to establish your counting patterns. So when you see x squared in the problem, you take any number in your head, let's pick something easy like 1, and you square it, and then you record the answer. And that's going to be your first counting pattern. So if I take 1 and square it, I get 1. So my first counting pattern is going to be out 1, up 1. If I do 2 squared, I get 4. So that's my next counting pattern, out 2 and up 4. 3 squared is 9. 4 squared is 16, and so on. We could go on and on and on. Now to make this a little quicker for the graphing, I do have these darkened lines here. Each of these represents 5. All right, so that should make it a little bit quicker for you to graph. But what you essentially want to do is you want to always start at 0, 0. So I'm going to put a dot right here. Let me change my highlighter color. That's a little bit hard to see. Yeah, green's a little easier. So we start at 0, 0. That's your vertex. From your vertex, you're going to apply your first counting pattern. You're going to go over 1 to the right and up 1, and then draw a dot. So 1, 1, and a dot. Then you put your pencil back on your vertex and you start your next counting pattern, which would be over 2, up 4. 1, 2, 1, 2, 3, 4. Then our next counting pattern, so from the vertex, we go over 3, 1, 2, 3, and up 9, which would be right here. And so on. So I'm going to go ahead and graph these other ones in my head real quick. 416. Just remember, you always start on the vertex. Every time you do a new counting pattern, always start from the vertex. And then 16. And 5, 25. Which would be right here. And then 36 and 6 will be right here. Alright, so what you have are a bunch of dots, and if you look, the space between these dots is getting further and further apart. Like these two dots, they're relatively close together. But then these two dots, they're a little bit further away from each other. And these two dots are further away. And these two dots are even further away from each other. So you see how the lines, the little curves I'm drawing, they're getting bigger, there's more space between them. That is what exponential growth looks like. Means every time you go to graph a next dot, it's going to be even further away than the previous dot was. That's the idea of exponential growth. And then what you would do is you would replicate that. You do it on the other side. We call that mirroring. So everything you did, you just mirror it on the left side, knowing that you want to have this U when you're all done. And then you would just connect all your dots and you got your nice pretty U. Now in math we have a little bit more of a sophisticated word than saying it makes a U. The word is called a parabola. So when you see a U, that is a parabola. That's the name of the shape. So anytime you graph a problem with a squared in it, you're going to get a parabola or a U. So what I want to do is take those counting patterns that you just learned and I want to include them with your shifting rules that we learned last time. If you recall, minus inside means go to the right, minus outside means go down. So I'm going to go right 2, down 3, put a dot, and that's my vertex. From there, I'm going to use my counting patterns that we just established. Over 1, up 1, and mirror it. Pencil back on the vertex. We go over 2 and up 4. Put a dot. Pencil back on the vertex. Go over 3, up 9, and you can see this nice U, this parabola, that's starting to emerge. Right, number 2 has a -2 out behind it. That's not in parentheses. So that means we don't go sideways, we go down 2. And then we apply our counting patterns. 1, 1, 2, 4, out 3, up 9, put your dots. See that nice pretty parabola? All right, number 3, +2, it's not in parentheses, so we go up 2. Now when we do our counting pattern, remember that this negative means that it's going to be upside down. So instead of going over 1, up 1, we go over 1, down 1. Over 2, down 4. Over 3, down 9. And so on. So we have an upside down parabola. Right. Go ahead, you can pause the video. See if you can use your counting pattern with your shifting rules by yourself in 4 through 6. And then when you're ready, you can unpause and see if you did it right. All right, let's see how you did. Did you go left 1, down 4, and then apply your 1, 1, 2, 4, 3, 9 pattern? Right 1, down 3 for the vertex. And then this one you should have gone left 3, up 6, and it needs to be upside down when you do your counting pattern. So the thing we want to work on right now is memorizing your counting patterns. And again, it's in the formula. You see the squared. You're just squaring however many you go sideways, you square that, that's how much you go up. So if you want to go sideways 8, great, but you're going to have to go up 64 because 8 squared is 64. So usually we stick with 1, 1, 2, 4, 3, 9, because those are pretty small, they're easy to graph. So in our next video, we're going to take it up a notch. Not only are we going to do shifting and counting patterns, but we're going to learn how to make the U's get wider and skinnier.